One potential problem with using expressions is that they can cause some confusion if a package is not executing properly because of a problem with an expression. Unless you open every task editor dialog box and review the expressions page, you'll probably spend a lot of wasted debugging time chasing false leads. New with integration services in SQL Server 2012 are expression adorners that display a small FX icon on the task to indicate that one or more of the task properties are set dynamically by an expression. This way, you can scan the objects in a package and find those that use expressions really easily. So this shows an execute SQL task, both before and after the task uses an expression. Notice the small icon in the upper left of the bottom image. That indicates that the task uses expressions. So if you're hunting down a problem, one that doesn't seem to be obvious or findable based on just configuring tasks or transformations or whatever, you can start looking for expressions and focus on just the components that use expressions. All right, let's talk about the language of expressions. I'd love to be able to tell you that the syntax used by integration services expressions is close to that of your favorite programming language. But, alas, that's not the case. Well, unless your language of choice is C# and you spend some time in Visual Basic and T-SQL. Because you'll see that there are elements of all three in the expression syntax, although it really is most heavily influenced by C#. Now, one reason for this mismatch is that integration services works with data from a variety of sources, ranging from SQL Server and Oracle databases to in-memory .NET data and a whole lot of other sources. But the technical reason why C# isn't the expression language is that integration services and the core SQL Server database engine are written using native code, and loading the .NET framework, or even a subset of it, would incur an unacceptable performance penalty. Besides, using a custom language lets the integration services team more easily add custom features that are specifically targeted at ETL types of uses. And applications. Anyway, you may not like the reasons, but it's the expression language that we have to work with. One thing you need to be careful of is that although the syntax looks similar to C#, the expression language doesn't support all native C# functions. It's not an implementation of C#. It looks like it, but it's not actually an implementation of it. So it doesn't support all native C# functions, much less everything that's in the .NET framework. You'll often find that integration services has functions of the same name and functionality, but sometimes with a different name. But as often as not, you'll find similar functions, but with different features. So there's really no way for me to give you general rules about coping with this kind of confusion. You'll just have to learn the syntax and what's available. Fortunately, the Expression Builder tool helps you write good expressions, particularly with the syntax error highlighting. And I'll talk more about that tool a little bit later in this course. Now, the go-to topic for integration services expressions in Books Online is Integration Services SSIS expressions. The subtopic, Syntax, has the details of the syntax with a link to another topic with a list of the available built-in functions. So lots of information about finding out what the expression language does. So what I'm going to do now is give you a quick rundown on the important elements of the syntax of expressions. Keep in mind that you can use expressions in both control flow and data flow tasks components, and the nature of the data in each can affect what you can do with expressions. Okay, first thing I want to talk about is identifiers. Expressions work with data, and that data has to come from somewhere. So you can use variables, both user and system, parameter, and columns. So you can use variables, both user and system variables, parameters, and columns in a data flow. When you're using a variable, you have to preface the name with the @ sign, to tell the expression evaluator that's a variable. So the evaluator doesn't look for a column with that name. The fully qualified form of referencing a variable is like this statement here. This uses the system namespace to disambiguate the variable and square brackets to protect against special characters, such as spaces, or if the variable name doesn't start with either a letter or an underscore. So really a good practice is to get in the habit of using the square brackets. It's a little bit more necessary than it is when you're writing straight T-SQL code within Management Studio. Now, if the variable name is unique across all namespaces for variables in scope and doesn't have any characters that require the use of square brackets, you can get away with this shortcut syntax for referencing a variable in expression. So this is going to reference the same variable as that fully qualified name example that I have above. But I really do recommend that you always use the fully qualified form in order to avoid problems later when you add variables to a package. Now, like a variable name, if a column name has embedded special characters or doesn't begin with either a letter or an underscore, you have to enclose it in the square brackets. Okay, so I talked about that. Also, column names in the data pipeline have to be unique. So you can use the dot notation to disambiguate a column name by source, such as something like mySource.firstName. And similarly, different variables with the same name that are in scope have to be in different namespaces, such as user : counter. And keep in mind that you can create custom namespaces. And it might be obvious, but you can only reference columns in a data flow within the data flow where they flow in the pipeline at runtime. All right, then referencing a parameter in an expression is similar to referencing variables, but with the addition of a $sign before the fully qualified parameter name like this. All right, next thing to talk about is literals. Expressions can include literal string, numeric, and Boolean values. String values have to be enclosed in double quotes, and there are escape sequences for special characters, things like /n for new line, /t for tab, // for a backslash. And then there's support for a variety of numeric values, things like integers, decimals, and floating point constants, as well as suffixes that specify how the expression evaluator evaluates various values. And then the Boolean literals are true and false, but these are not case sensitive, and they have to be delimited by spaces. The expression language supports a rich set of operators, which should be generally familiar if you use C#, VB, or Transact SQL. But there are a few notes about operators in integration services. First is that there's a namespace resolution operator. I've talked about that a lot. You use this to disambiguate variables that have the same name that's in scope. There's a cast operator. The cast operator syntax is similar to that in C#, so you place the data type name in parentheses in front of the value to cast. So an example is a DTI4 to cast this numeric value, 3.14, to an integer. And then, just to note, the equality operator is two equal signs, just like C#. Assignment operator is just a single equal sign. The string concatenation operator is a plus sign, and that's going to be pretty comfortable for anyone with a C-based programming language background. But for VBers, you can't use the ampersand for concatenation, sorry. Now, an important topic when you're talking about integration services, particularly because it often uses the data from a database that supports nulls, is how you work with nulls. The problem, or the issue, is that variables in an integration services package can't contain null values. And again, this is because of the COM object variant implementation of variables. Instead, each data type has a default value that indicates the absence of a value. Unfortunately, all the default values are actual values, so it's not as neat as nulls are in SQL Server. So for example, a string's default value is an empty string. Numeric types have the default value of 0. For date times, it's a little bit messier. The default is 12/30/1899, 12 a.m. if you set it to null. Now, that's an important qualification because when you create a variable of this type in the variables window and you specify it as a date time, the default value is set to the current date and time, today or right now. So that's not really the default value of the data type. It's a little bit misleading. And then a Boolean has the default type of false. Okay, so my mentioning of datetime probably raises the issue. If variables don't support nulls, how can you set a variable value to null so that it takes on its default value? Well, it's easy, if kind of a bit convoluted. You simply use the null casting function on the data type. So for a datetime type, which the integration services datetime type is dt_db timestamp, so use the null function, pass in the data type, and then assign that to the value of that variable. And so this is not going to assign a null, but it's going to get the value of 12/30/1899 at 12 a.m. in the morning. Now the good news is if you use the expression builder, the GUI interface for building expressions, it includes a list of the null functions with the proper syntax. So you don't have to remember what all the different data types are. All right, now on the other hand, data flow columns have to be able to contain null values, since many data sources, including SQL Server and destinations, support nulls. So you can use the built-in isNull function to test for nulls and null typecasting functions. So you have support for nulls when the data type actually supports a null. But the absence of nulls in variables, but their use in data flow columns, can create problems when variables are mixed with columns in an expression. And that's a problem within scripting code as well. Since there's no support for nulls in variables, you have to decide ahead of time what value indicates the absence of value, so that you can then test for it. Sometimes the default values work. Most of the time 12/30/1899 works just great. But that's far from always the case. So it's just a little bit of messiness that you just have to deal with. All right, then there are conditional expressions. Good news here is that the expression language uses C#'s ternary conditional expression operator, which is that Boolean expression, question mark, Boolean expression, colon, expression. And that builds an if-then logical structure for you. The syntax for the operator looks like this. The expression evaluator starts by evaluating the Boolean expression. If the result is true, it then evaluates the expression if true parameter, and then returns the value of that expression as the value of the overall expression. But if Boolean expression is false, it instead evaluates the expression if false after the colon there. So if you're not used to this syntax, it can be a little bit confusing at times, but once you get the hang of it, it's really a pretty elegant way of building if-then logical structures. Okay, so at this point, I've given you just a small bit of the overall syntax of the expression language in integration services. There's a lot more to study, but remember that if you're familiar with C#, VB, and T-SQL, it'll all seem pretty familiar, yet different enough to trip you up when old habits kick in. The biggest problems you'll encounter will probably be with data types and conversion. So be on the lookout for a situation where conversion issues could lead to erroneous results or errors. All right, I've mentioned the expression builder several times, so let's talk about that. Now, any place in the package designer in SQL Server Data Tools that lets you use expressions makes available a nice little GUI expression design tool, which is called the expression builder. The tool provides access to the list of variables, including variables in both user and system namespaces, as well as any custom namespaces that you create, as well as lists of functions and operators that you can use. You can either type in expressions directly or use the tool's drag and drop features to build expressions, which is a great way to learn expression syntax. Best of all, it provides instant syntax validation, and in the control flow provides the ability to test an expression so you can be confident it's producing the correct results. Now, the expression builder is mostly the same in control and data flow components, but there are some differences. And there's really two main ones. The first is that in the data flow components, the upper left list provides access to the columns in the data flow pipeline, since you can use that data in an expression. The control flow component can only use variables and parameters. And then the other difference is that in a control flow, the tool lets you immediately evaluate a syntactically correct expression so you can repeatedly test whether the expression is producing the results that you want. In a data flow, the data in the pipeline isn't available at design time, so there's no evaluation option. But you can configure error output in many cases. All right, so there's the expression builder within the control flow. As you can see in the lower left, there's an Evaluate Expression button that once you have an expression, you can evaluate it and the value will be displayed within the Evaluated Value box near the bottom of the dialog box. But otherwise, upper left gives you access to variables and parameters, as well as all of the functions and operators that are available that you can use. And then here's the equivalent for the data flow. Notice the lower left has Configure Error Output, so that you can configure output, because this is in the context of the derived column transformation editor. So a little bit different format, but a lot of the same kinds of features. Same basic functionality is available.